Hello everyone. So in this session we'll just have a look on a demo on valve industries. So we'll just consider this valve into account. Okay, so to have a clear vision, I'll activate the section view so that we can see how the valve is placed inside the valve. It is kind of like rotated. To define study, we should activate the wizard, and here we could able to add up the project name, that is valve flow analysis. Once you define the project name, you could able to deal with the parameters and the unit system. You could able to change it as per your requirement, but right now I'm keep as default here. We do have the option to define the analysis type as internal and external, so I need to deal with internal flow here. And the fluid, we could able to choose different fluids, so right now I'm going to deal with water. Okay, and the parameters, that is adiabatic juice and roughness is 0 microns. And finally, to deal with the velocity and the thermodynamic properties, I'll keep these as default. Once we set up the wizard, system gonna automatically define the fluid domain. If you want to modify that, we could utilize the computational domain here by just using the arrow keys, as well as by utilizing the manual method. Yeah, so after this I'm gonna set the boundary conditions, so inlet flow and the outlet flow conditions. And here I'll choose the inlet lead as a count, and I'll define the inlet mass flow here. So let's say it's 0.8 kg per second. You can even set the unit to meter cube per second while setting up the wizard. So for now I'll keep 0.8 kg per second. Yeah, so we could able to deal with the output. We should define it, so output pressure, we can define the static pressure or the environmental pressure, or the, if you have the values, we could define it. Not only inlet mass flow, we have the inlet mass flux and the volume flow and the inlet velocity also we could define. Okay, there are multiple options to deal with. And next thing is to add the outlet condition. So here I'll utilize the environmental pressure, and I'll define. And if you want, you can define the static and total pressure. Yeah, so once you define your boundary conditions, I need to deal with the goals. So here I'll apply the goals. So that is to deal with the global as well as different kinds of goals are available, that is surface and the equation based goals we could set up. And here I'll just consider mass flow rate, that is maximum mass flow rate, and the velocity average. So these two I have set up for the global. And for surface based, I'll select the inlet and outlet surface, and for this I'll define the velocities, the average velocity or the maximum velocity. And we could utilize that create a goal for each surface, so it's gonna create the separate goal for each surfaces. I'll choose the maximum velocity for this here. Okay, so once you define the goal, we can utilize the meshing. So there are multiple kinds of meshes are available, so advanced levels, and by just setting up these levels here, I'll utilize the default for now. And finally, to run the results, I'll simply select the run. So if you select the run, software gonna automatically mesh it by utilizing the default mesh method, or if you want to generate the own mesh, you can set it up by defining your advanced meshing. Okay, and while processing the solver, we could able to get the charts and even the flow results, and it's gonna take some time to generate the mesh as well as the flow results. So this you can here see the calculations, and here to add the graphs you can select the studies which you want to deal with, that is goals. I want to deal with these two graphs here, so automatically these graphs will be shown and how the modifications are going with respect to iterations converging. Okay, and the convergence has achieved at 40 and 50 iterations respectively. Finally, we have the results. There are different kinds of plots available, the cut plots and surface plot. Here to deal with the cut plot, I'll utilize the front plane as a reference. Okay, and here in the contours you can set up the pressure or the velocity. If you just select this show icon, it's gonna show the output. So we could able to see the pressure value in the form of Pascal, and if you want to change it to velocity, we simply use the contours and set it to velocity. We do have the options to set different options like vorticity and other steps there, and ISO lines as well as the vectors and streamlines also you could define, and you can increase them as per your requirement. Okay, so right now, and even this, by utilizing this particular knob we could able to set the front plane wherever we required at the offset distance. Yeah, the final thing is to just hide this one and deal with the flow trajectories, how the flow is taking place through this. So here let me just define the inlet, and here we can modify the appearance. So right now I'll select the velocity and the pipe as the default appearance. Okay, this is how it's gonna look. The velocity is 12.5 meter per second here, and I want to modify this, otherwise I want to just animate this one first. You could see this is how the animation is generated for this. And we could modify this by using the array definition, and by just setting this appearance type to arrows or sphere and the arrow flat. There are different types available. Right now I'll choose it as arrows, and I'll keep this one default. Once I do that, we could able to see this is the output, and if I animate this, this is how it's gonna distribute. Yeah, now I want to utilize entire model into account, so that I'll just turn off this section view and I'll change the appearance like display transparency, so that we could visualize the entire flow simulation on the models by just changing the appearance type here. Yeah, I have changed the entire model appearance. To transparency mode, so that we could visualize it. Now I'll deal with the goals. I'll select the goal plot and I'll insert the goals which I needed. Here we have the option to select all the goals, and if you want specific goal we could select it, and if you want to transfer to Excel sheet, that also is possible. We could able to visualize all the results, that is flow rate and the average velocity and the maximum velocities on both the inlets and outlets. Yeah, so finally we are done with this here. So I'll just change this particular the size of the arrow marks, so that I could have a better flow visualization inside the valve. What I'll do is I'll just reduce the arrow size to 0.00025, so that the size of the arrow will be reduced, and I'll increase the number of points to 300. Okay, now I'll just deal with the visualize now, how it gonna just give the visual appearance of this. Yeah, this is quite good for me. I'll just animate this. Yep, this is quite good, and you can just set your model, and we could able to see as per the ball rotation inside, the flow is just diverted, right? Yep. That's all about this particular demo. We have covered the SolidWorks flow simulation tools and the basic procedure to how to deal with this.